Looking at applications of integral calculus, I have this question here: the rate of change of position, velocity that is, of a particle travelling in a straight line is given by dx dt equals 40 minus 10 e to the negative 0.42 metres per second, where t is greater than or equal to 0. X is metres, t is seconds. Find the velocity initially and after 10 seconds. Okay, so just remember our relationship there we've talked about before in differential calculus between displacement, velocity and acceleration. And if we differentiate this way, we get our equations for velocity and acceleration. So differentiate, and if we integrate back the other way, we get our equations for velocity and displacement. So that's an important little diagram to remember, because this comes up from time to time. So let's look at this question though, because the first part we don't really need to know that, because we're just finding out the velocity, and our equation for velocity here is that one there. And we're finding the velocity initially and then after 10 seconds. So let's look at velocity initially. So, if you like, we've got our equation there, dx dt, but we can actually almost call it v for velocity, same thing. 40 minus 10 e to the negative 0.4 t. Remember, when we're talking about initial velocity, we make t equals 0. So negative 0.4 times 0 equals 40 minus 10 e to the 0 equals 40 minus 10, which is 30. So there we go. We've got our initial velocity, and we must remember our units. It's metres per second. Velocity after 10 seconds, so same thing once again. Velocity equals 40 minus 10 e to the negative 0.4 t. Velocity equals 40 minus 10 e to the negative 0.4 multiplied by 10. There's our 10 seconds. Equals 40 minus 10 e to the negative 4. Equals 39, if we work it out in a calculator, 0.82. Not a very good 9. Let's try that again. 39.82 metres per second. So there we are, we've answered that first question. Okay, question B. Find the time taken for the velocity of 35 metres per second. So we've got our velocity, it's 35 equals our equation for velocity, like so. Now we can put that in the calculator as is. Okay, but you can progress a little bit further before we go to the calculator. For example, if I take the 40 across to the other side, I get neg 5 equals neg 10 e to the minus 0.4 t. Then if I divide through here by negative 10, I get 0.5 equals e to the negative 0.4 t. So I can progress things a fair way before I go to the calculator. I could even convert that to log form if I wished. But I'm quite happy there for you now to go solve. You can use x or t, it doesn't matter. 0.5 equals e to the power of negative 0.4 t, comma t. And you should be able to get your answer there. And to 2 decimal places, it's 1.73 seconds. Okay, so, once again, I've stressed this before, you could actually just put that in the calculator if you wish. And you weigh up the time, but I think, if you're showing as much working as you can in the exam, it really helps. Okay, because if you've mucked it up, at least you're showing you've got some algebraic skills. Eventually, of course, we have to go towards our calculator. Next question. Sketch a graph of dx dt against t. So that's a matter of putting this graph here into the equation. Into the calculator and graphing it. And you can see I've done that there. I've kept all the axes in. You might think, well, gee, here's a lot of wasted space here, Mr. Moore. But I've kept the axes in. I've gone from 0. You can just probably see the 0 down there in the bottom left-hand corner. And I've got my graph there. That's the graph of the derivative. That's the graph of velocity. Because remember, dx dt is our equation for velocity. Okay, next question. Just realised I hadn't written the question out. So there it is, question D. Find the total distance travelled in the first 10 seconds. Now, some of you have done physical science, others of you haven't. And in physical science, you probably know by now that to find the distance from a velocity time graph, you actually find the area under the graph. So, if I draw a line from 10 down the bottom here, up to the graph, okay, it's not very straight, but anyway, that space inside here, I won't shade it all in, but that space inside there, okay, that area under the graph actually gives me the distance travelled in the first 10 seconds. Okay, so what I need to do then, area under the graph is integral from 10 to 0 of 40 minus 10e to the negative 0.4t dt, and remember you can use x's if you wish. Now you can work this out, we can do it the long way, but really from there it's just a matter of placing that integral into our calculator, and our distance travelled is 375.46 metres. So there we go, there's that one. Oops, there was that question. Alright. The rate of change of pressure P atmospheres of a given mass of gas with respect to its volume V cubic centimetres is given by this equation. Here we are. To P to V equals negative K over V squared. Our old friend K has come back again. It crops up everywhere. So that's the rate of change of pressure. If to P to V equals -5 when V equals 10, find K. So let's just focus on that. First of all, that question there. Okay, so we know that to P to V equals negative K on V squared, and we're told that if to P to V equals -5, there it is, when V equals 10. So equals negative K over 10 squared. So that will enable us to find K. Multiply -5 by 10 squared. We get negative 500 equals negative K, which of course means that K equals 500. So we've found the answer to question 8. It's 500. So K equals 500, which means our equation for to P to V equals negative 500 over V squared. Next question, question B. Sorry, it's a bit small there. Find the pressure P as a function of V given that when P equals 10, V equals 50 cubic centimetres. Right, so we're finding a equation for P. So remember, if we're going from a derivative to P to V, which is a rate, same thing, remember, equate those things, gradient, rate, derivative. To find an equation for P, we've got to integrate. Okay, so P will equal the integral of negative 500 on V squared. Now we can separate out here this integral, so we get p equals negative 500 integral of 1 over v squared. Continuing over here, so p equals negative 500 integral 1 over v squared is v to the neg 2. P equals, and of course we should be putting here plus c, not there, but actually I won't do the plus c just yet, we'll do the integral first. So negative 500, raise the index by 1, is v to the negative 1 over negative 1, like so. So that's going to equal two negatives, so we've got negative 500 over negative 1, there and there, that's going to equal 500. And we can put the plus c here now, by the way. V to the neg 1, actually I'll just put that down a little bit further so we can see it a bit better. So P equals 500 V to the neg 1 plus C. Just once again, I just want to be really clear why we get positive 500 there, because we've got negative 500 over negative 1. Okay, equals, so P equals that. So P therefore equals 500 over V plus C. Right, how are we going to find out plus C? Well, back to the question again. Find the pressure, so pressure equation, okay, as a function of V. And you be careful with that, because I've seen people look at that before and go, find the pressure, and they're looking for a value. What it's asking there is find an equation for pressure as a function of V. Give it there in P equals 10, V equals 50 cubic centimetres. So we can now put those two bits of information, that one there and that one there, into the equation to find our C. So 10 equals 500 over 50 plus C. That means 10 equals 10 plus C. C is actually going to equal 0. So our equation for pressure, answer to question B, is 500 over V. Simple as that. And question C follows on from that then. Find the volume when the pressure is 20 atmospheres. Okay, so pressure is 20 atmospheres equals 500 over V. Okay, swap those over, as we usually do in this situation. V equals 500 over 20, and that's going to equal 25 cubic centimetres. And we're done. Last question for this video. Find the rule of the function corresponding to the arch of the bridge. Alright, so that red graph there, we have to find the function. Let's see how we go about that. Okay, so we have to find, we've got a red graph here that we have to find an equation for. And I didn't write the question out here, so the arch, I'm just reading this is question 11 on page 448. The arch of a concrete bridge has the shape of a parabola. So there's our arch there in red. And the concrete bridge is built around the arch. Okay, so here's the bridge, travelling over the bridge there, and we've got the arch as part of that bridge. Alright, so it's a parabola. So it's going to be y equals a outside of x minus b squared plus c. That's our general form for a parabola. Now, if you look at this parabola, its maximum is at 0, 6. So because its maximum or minimum is at 0 for a parabola, it hasn't been shifted left or right. So that means it really is y equals ax squared plus c. Now straight away, because it's the sad face, we know that the value of a, the number in front of the x squared, is going to be negative. Okay, that's that dominant term we've talked about. But I'm not really too worried about that at the moment. What I'm worried about is where this graph has been shifted, because given that the original graph would have been here, okay, it's now gone up to 6. So it's been shifted up 6 places. Okay, so what I know about my graph, it's at y equals something x squared plus 6, and I know my value of a is going to have to be negative. Now, how are we going to go about finding a? Remember, we use one of our points, and one that we can use here is this point here. We're going to use, and I'll just clear off this so we've got a bit more space. We're actually going to use the point 4, 0. Try it yourself with other points and see how they go, but sometimes those x-intercepts are good ones to use, because if I put 4, 0 into the equation now, I get 0 for y equals a times 4 squared plus 6. Remember, this is our general approach to find an a value in any of these types of graphs. We substitute in a point. So 0 equals 16a plus 6. Negative 6 equals 16a. Negative 6 on 16 equals a. Cancel that down, we get negative 3 on 8 equals a. So our equation is y equals negative 3x squared on 8 plus 6. Our next task is to find the area of the shaded region. So our approach, as per usual, is we've got a rectangle. Okay, so we've got a rectangle, and that's going to be, let's see, we've got a length there of 5 to neg 5. So that's going to be, neg 5 is not put in there, but it's there. That's going to be a length of 10, and a height, you can see there we've got the point 7, so it's going to be 10 by 7 equals 70 square metres. Now, we're going to subtract from that the area of the red curve, so we're going to get area equals 70, which is the area of the rectangle, minus the integral from 4 to neg 4, it's above the axis, negative 3x squared on 8 plus 6 dx. And we can put that straight in the calculator as is, and the area that we end up getting is 38 square metres. Please try that for yourself. Pause the video now. Okay, we can now have a look at the last question here. If the bridge is 10 metres wide, find the volume of concrete on the bridge. So remember, we're sitting on the river at the moment looking through the bridge, but the bridge is actually a 3D structure. So it's got 10 metres wide that way. Okay, it's 3D, so it's going to go down the back there as well. So all we have to do there is multiply our 38, which is the area of our cross section, okay, the pink area, multiplied by the width of the bridge, okay, and so it's, equals there. So volume equals 38 by 10 equals 380 cubic metres on this occasion. Okay, now I'd like you to do exercise 9J number 1 and 2, number 4A through to C only, 5 through to 8, number 12, and if you're brave, some really tricky ones there, have a go at numbers 9 and 10 in 9J. That's all for now. Hope you enjoyed this video.